everybody, welcome back. In today's lesson, we're going to discuss the electromagnetic spectrum. So remember, the electromagnetic spectrum is made up of different types of waves, and there's 7 specific waves, and then they are also arranged according to their wavelengths and their frequencies. Just before we start, remember, electromagnetic spectrum is different from the visible light spectrum, and that's also what we're going to discuss. So let's look at the definition of electromagnetic spectrum. So it's the range of wavelengths over which the electromagnetic waves are spread. So remember, there are 7 types of electromagnetic waves. It's the radio waves, the microwaves, the infrared, visible light, the ultraviolet, the X-rays, and the gamma rays. Now, these 7 waves are arranged according to their frequency and their wavelengths. Radio waves have the lowest frequency, which means the waves are very spread out, and therefore they have the longest wavelength. While gamma rays have the highest frequency, which means the waves are very close to one another, and therefore they have the shortest wavelength. It's very, very, very important to remember this order and always pay attention to what they are asking. Are they asking you to arrange these waves according to increasing wavelengths or decreasing wavelengths, or increasing frequency or decreasing frequency? Remember, if you need to arrange according to increase wavelengths, it means you need to start with the shortest wavelength and end up with the longest wavelength. So then you will start with gamma rays and end with radio waves. If you need to arrange according to, let's say, increased frequencies or increasing frequencies, then you need to start low and end high. Therefore, then you're going to start with radio waves and end with gamma rays. So always pay attention to what they are asking you. So here you can physically see the electromagnetic spectrum. You can see here our radio waves. They are very spread out. So if they are very spread out, it obviously means they have the lowest frequency and therefore the longest wavelength. And then you can see as we are moving towards the gamma ray side of the spectrum, the waves are starting to get more close to one another. And the reason therefore is because the frequency are starting to increase as we move across the spectrum, and therefore gamma rays have the highest frequency because their waves are the closest to one another, and therefore they have the shortest wavelengths. Just something you need to pay attention to is there is a difference between the electromagnetic spectrum and the visible light spectrum. Always pay attention to what spectrum they are referring to. If they ask you something about the visible light spectrum, then they are talking about Roy G. Biff, meaning red, orange, yellow, green, blue, indigo, violet. Now, the visible light spectrum is also arranged according to wavelengths and frequency. So you will see that the visible light spectrum is obviously arranged according to Roy G. Biff, and then red light has the longest wavelength with the lowest frequency because red light, the waves of red light are very spread out, while the waves of violet light are very, very, very close to one another, and therefore they have the highest frequency with the shortest wavelength. So always remember, if they are referring to green light or blue light or indigo, violet, whatsoever, they are referring to the visible light spectrum. And remember, when they're talking about radio waves or microwaves or gamma rays, they are talking about the electromagnetic spectrum. Now let's look at a few examples of the applications of electromagnetic waves. Now, radio waves, examples of where radio waves are used is within radios and TV broadcasts and navigation systems. Microwaves are involved in cooking purposes, satellite communications, radar speed traps and radar tracking, as well as our cell phones. Infrared rays are involved in conventional ovens, toasters, heaters, or cooking and heating purposes. Or infrared lamps for treatment of muscle pains, as well as used for improved night vision. Then visible light is used by humans so that we are able to see the 7 rainbow colors. Then ultraviolet rays. Ultraviolet has to do with also the sun's UV rays. So it's used to verify authenticity of banknotes, optical clarifiers in washing powders, so it's used to make clothes look brighter or even whiter. It gives the tan color to the human skin after sun exposure. It's because the sun shines its ultraviolet rays. And then it's also used to sterilize apparatus in hospitals. Then X-rays are used to take photo images on a photographic film for medical diagnosis, meaning to take images of broken bones or detect broken bones. It's used via CAT scans and then X-ray detectors to detect weapons in luggage. In our last wave, the gamma rays, they are used to destroy cancer cells during radiotherapy. It kills bacteria and sterilizes food and medical instruments, and then it's used to keep food fresh for longer. Now let's look at the penetrating ability of electromagnetic radiation. So what is the rule regarding penetration of these waves? So the higher the frequency of the wave is, the higher the energy it contains, and therefore the greater the penetrating ability and the damage it can do to our cells. So in short terms, penetrating ability is about waves. If they are having higher frequency, it means their ability to penetrate the human body is greater, and therefore the most dangerous electromagnetic rays are the ultraviolet rays, the X-rays, and the gamma rays. So the 3 waves that are lost on the electromagnetic spectrum, and that's because they have the highest frequencies, which makes them having the higher energy and therefore the greater penetrating ability, and therefore they can cause a lot of damage to our cells. But then why do we say that ultraviolet rays, X-rays and gamma rays are very dangerous, and what consequences can they have on the human body? So ultraviolet rays are dangerous because they can penetrate the outer layers of the skin. That's why we can get sunburn. It's because the ultraviolet rays penetrates our outer layers of the skin. But what can happen if we get overexposed to these rays? It can lead to aging, skin damage, even eye damage or cancer. And then X-rays. X-rays are dangerous because they penetrate the skin and the soft tissue, but it's absorbed by the bone. So that's basically a property of them. And then if you get overexposed to X-rays, they can cause body tissue damage and even cancer. And then gamma rays, the most dangerous rays of all types of electromagnetic rays, and that is because they penetrate right through the body. And then overexposure to gamma rays can lead to completely destroying tissues, it can lead to mutations and even chromosome defects. And that's it. That's the end of Wave, Sounds and Light. Thank you for watching. Please stay tuned for our next videos.